Apptronik. At Apptronik, we're focused on bringing the next generation of robots to the world. So what does that next generation of robots look like? Well, it's centered on this trend of human-centered robotics, where humans and robots are working together in close proximity. It doesn't really exist that much today, but it's emerging and it's going to be a heavy player in the next 5 to 10 years. Now, how do we know that? Well, at Apptronik, we have extensive background work with some of the most advanced robotic systems in the world. Work with Mecha, which was acquired by Google during their buying spree. Valkyrie, which is a NASA-UT joint entry into the DARPA robotics competition. And even with Asimo, which was the most well-known friendly faces of robotics today. So Apptronik is a spin-off out of UT Austin. It's a human-centered robotics lab, which is led by Dr. Luis Sentis. He has a background in Stanford and Silicon Valley, and is a very smart guy. We also have the military leadership and business acumen of retired General Bill Welch, who's our CEO. And we have our tech guru, Nick Payne, where most of our tech advances and developments come out of. We also have Jeff Cardenas, who is with IC Squared, and he brings his commercialization expertise to the table. So we're well poised to help usher in this next generation of robots. We're very committed to that goal. I'll say that many times throughout the presentation. But we already have a contract with the Navy to develop a pair of super high-end advanced robotic legs using some of our key technology. But one thing that makes Apptronik different than other companies that do engineering and robotic solutions is we want to take those key developments out of our R&D section and put them into a catalog that makes it available for everyone who wants to build a robot to use. Because we think that's critical to bringing this next generation of robots to real fruition. So you want to build a robot, right? What are you going to focus on? So there's 4 main things. You have your software, your embedded controls, your actuators, and your sensors. Now, who actually deals with these? Who builds robots? And for our purposes, it's these guys. The collaborative robotics market is the technical portion where human-centered robots really comes into play. It's about $100 million, and it's growing by 50% every year. Despite that size and that rapid growth rate, it's still relatively in its infancy. What we care about, which is mobility exoskeletons, force enhancement exoskeletons, and humanoid robots, there's no real powerhouse player in the market that's dominating everyone else. And all of these guys face one problem, mainly one large problem, which is lack of standardization. Advanced robotics lacks standardization, which makes it very expensive to create a full robotic system. It's expensive. It also delays their entry into the market, which is something that they very much care about from talking to them. And it is also just in general inhibiting this advancement to the next generation of robots. So at Apptronik, we're focusing on the embedded controls and the actuators, because that's our specialty, and that's where we also think we can provide a big advantage. Around 30% of the developmental costs, be it paying the engineer or actually machining the stuff, comes from actuator design, development, and integration. So we specialize on high-performance series elastic actuators and control systems. Now, what is an actuator, you might be wondering? So just a brief overview. An actuator is what allows the robot to move. It's the robot muscles. There's 2 types. There's rotary and there's linear. We have a linear robotic actuator developed, but it is very applicable, the key technology portions, to a rotary actuator as well. So when you're deciding on an actuator system, besides linear and rotary, you also have to look at the way that's powered. Well, before I say which of these things we're talking about, there are 5 areas that you need to focus on. Efficiency, impact tolerance, how many hits it can take, force controllability, how much force or what force can you get out of it that you want, and position controllability, can you put that force where you want it to go, and continuous power density, which is how long can it work at its peak performance. So hydraulics pretty good at everything except efficiency, where it really lacks. But that hasn't really been a big problem for robots that are, for the most part, just bolted to a factory floor. But the next generation of robots are going to be mobile, and that becomes something you can't compromise on. For electric, they're great at efficiency and position control, but they really suffer at impact tolerance, force control, and continuous power density. And for a robot that's mobile and walking around, you need to have a sturdy and reliable bot. And that means you can't compromise on impact tolerance and force controllability at all. So with these in mind, they created it was created, the series elastic actuator. The key element here to focus on is this spring sensor deal at the back. And that's what really provides the benefits. It gives you back impact tolerance and force controllability while having the efficiency of electric. But it does suffer in position controllability because you're inputting a sensor into this whole system. Or sorry, not a sensor, a spring. And springs wobble. And that's actually not that funny, because when you have robots and humans working together in a very close environment, such as with collaborative robots, that's a potentially deadly situation. So again, another thing you can't compromise on for this next generation of robots. And then also continuous power density is very important for extended use. You don't want something that can then just work for 5 minutes. So with this in mind, Apptronik created the liquid-cooled viscoelastic series elastic actuator, very long name. But the key element here is the reflex technology, which is the viscoelastic portion. And that actually brings back that position control that we so desperately need in collaborative robots. We also have a liquid cooling jacket, and when you see those two technologies that we provide put back into the equation, you actually get the best of both worlds for hydraulic and an electric series elastic actuator. And this is what we have at Apptronik. We also, in addition to an actuator, you need something to control them, otherwise they're a little less useful. We've been noticing some people are ripping out their control boards, some industrial integrators, so they buy robotic systems and then they purpose them for people who need them. They're ripping out the boards because it's not meeting their needs. So we provide a very fast, completely open control board so that roboticists around the world can have complete access to their systems, which we think is very important. It's about 10 times more responsive than standard control boards, so you get a much faster ninja-like robot. So the liquid cooling here is another wow numbers kind of thing, but it is important. It gives us about 50% more speed than a regular series elastic actuator and 300% more power. And you can put a liquid cooling jacket on a lot of motors and get a lot of improvements, but this is significant because it's one of our IP objects as well, and how it attaches and the modularity of the whole system. Liquid cooling is also very important because right now noise is one of the biggest problems for adoption of and the growth of these advanced robotic systems. Air cooling is a very loud thing. IBM switched to air cooling briefly at one point, I believe, and then went back to liquid cooling because it was too loud. And that's for people that are just sitting in an office with robots. Imagine this is walking around and it's all around your daily life. So the military also complained about this for some of their carry-in robot applications. It's just too loud. So liquid cooling can help you get that actual sleek profile that you expect out of the next advanced robots. Meeting the performance criteria that you've expected or set already. So with that, it was a brief overview. I'm open to questions, but I'd like to welcome you to the next generation of robots. They're going to be powerful, agile, efficient, and robust. I'll let you guys picture what that's supposed to look like. So, any questions? Yes. Pardon? So for like the exoskeleton people. True. Yeah. Yeah, that's one of the things that I'm most interested in learning throughout the ATICL program. Is you raised a lot of really interesting points that I've been thinking about all night. But it's exciting because I want to see if it's possible. So you're take our IP and apply it to other actuators that people already use? Hot swap. Yeah, that's definitely something I want to pursue, and I've thought about that a little. But as I said, right now we want to get down very narrow, so we can execute very narrowly. And then in the future, there's a lot of big opportunities. And so I presented some of the big opportunities right now because we don't have entirely that narrow stuff.
I think that's. sell it to R&D.
Right. So we don't want to stay in an academic space. That's not our goal. And I agree. That's a dead end. I believe is what you're getting at.
So I think the point to kind of jump on what he said was, there's a lot of actuators being used already, right? You built a better actuator and you built a control board. Maybe actually going after some of the markets that are there. I think you moved all the way to the humanoid. Can you productize what you have?
Yeah.
I think that's what Shane's saying is that there's ways that you can build a roadmap to eventually get to all the parts for humanoids and all that.
No, we
There's probably
want
existing
that.
market with some of your benefits. It's like saying I'm going to do a pest control company, and so I'm going to buy trucks and do all this stuff, and I'm going to show you the pest control. And really, you got a better mousetrap.
Right.
Just sell the mousetrap to start with. I'm not saying that's what you should do, but there's a way that you could productize and actually fund to your long-term goal.
Yeah.
But I think bring us back to the exercise and not to like redoing your plan. I think over the summer, doing a roadmap of what you can do and how much money it will take will probably drive you to some of those decisions anyway.
Definitely. That's a great idea.
To follow up on that, I'm reminded of the story of the real McCoy. Do you know that story?
I'm not familiar.
Back in the 1880s, there was a guy who invented the oiler for the steam engine, and it was the best oiler that ever came along, and people wanted the real McCoy. With what you presented here, it sounds like you could become the real McCoy of the robot world. And all those names on your list of all those robot companies, they want the real McCoy because your actuator is better than theirs. So to follow on what Dave was saying, sell the actuator and let them know what the benefits are, why yours is better, and have them build yours into their robot and have everybody out there beating a path to your door.
All right.
If I can follow on to that.
Thank you.
I think combining the analysis of which markets this actually matters in with the go-to-market and whether it's licensing versus selling the embedded component, how standardized can this be? The less standardized it can be, perhaps the more it makes sense to do a licensing model instead of a manufacturing model, even for the embedded component, right? The real McCoy across everything would be great, but you can't build everything for everyone. So is it so standard, or do you take a step back and license instead of build? I don't know, but maybe that becomes part of the
Or both.
Or both, yeah.
I think the biggest question here is there is no market for it. There is no forecasted market for humanoid versus skeleton and with an actual company using the components you may sell 10,000 of these a year. That to how are you going to make money?
Right. Right now we're.
That is the biggest question we have to answer. There's no industrial robot makers in the private sector.
Yeah, we talked about that, and I see why now.
That's why you get a lot of magnitude, but it's not even important.
So right now we're just stringing along. We have the Navy contract. We have a contract with NASA to develop more viscoelastic elements that can potentially go in and expand the use case. But yeah, we have grant funding. We have SBIR funding. We have that kind of support. But we do need to figure out where we can actually find that first customer. I guess is the goal of the summer, is find the first customer.
Stay away from robots.
All right.
I think aren't actuators being used in other things than robots?
Oh yeah.
So my point wasn't to go after robots. My point was go look at the actuators. I think that's where he was about licensing.
Yeah, we just heard back from today, Moog, which is they make actuators for people. They're more custom.
1 minute.
And they are interested in talking to us about aviation and the application of our technology to aviation. So we've been looking at those, such as construction, mining was another one that relates really to construction, and then I'm blanking on the other ones, but I'll get back to you.
But there's other markets.
There are. The whole point is that I agree with completely. There are other markets. This is